Today we're going to go through comparing linear. Show me with your arm what a linear looks like. Straight line. Very good. Exponential. Show me with your fingers what exponential looks like. Oh, maybe your hand. Yeah, that's kind of cool. Yeah, that'll work. Okay, it's a bit of a slope. And quadratic. Good luck. Yeah, maybe use both your arms. Yeah. Yeah, it's a field goal. All right? Very good. Hey, you guys, there are your graphs. Okay? These are the different forms that we've talked about so far this year. And comparing them, if you're looking at the equation and the picture, and we'll also look at the table today, they all have distinct qualities. So linear, picture, forms a straight line. Is in the form y equals mx plus b. X is to what power? Yes, first power. Okay? Exponential is in the form y equals abx to the power of x. X is in the power position. It has that curve. It goes up really fast. Okay? And then quadratic, x is to what power? Second power. That is the highest power. It is a U-shape. Okay? So what we're going to do is we're going to be, I'm hoping from picture you already can tell, and I'm hoping equation-wise you can already tell. But we're really going to dive into what it looks like in terms of a table as well. All right? So first step, let's go ahead and look at problem number 1. Okay? 1 through 4, let's start with number 1. Plot the points, tell whether the points to be represent a linear, exponential, or quadratic. Off you go, give it a shot. Actually, do 1 and 3 right now with your groupies. Come on, man. I'm sorry I left out 2 and 4. Tyler wants to do 2 and 4 right now also.
Yeah, I want to do all of them.
You do 1 and 3 just for now. Okay. Let's go ahead and see how we did.
Number 1.
Number 1. What is it?
Quadratic. Quadratic.
It's pretty quadratical, yes. Number 1.
So you change.
Okay, get the U shape if you were to connect the points. Now you may have made your axes in different spots. That's okay. What was number 2?
Wait. I'm not done with that one. No.
Or, sorry, number 3.
I'm not done.
Wait, I'm not done with that.
Yeah.
First one's
I know, you guys got to pick up the pace.
Got this.
Okay, yeah, the second one, or the third one there is exponential. Okay? Now, if you're like, I couldn't tell if it was linear or exponential, you've got to start looking at your rate of change, right? Is x, as x is going up by a constant, is y changing the same amount each time? And the answer is no. Okay, so in this case, exponential. All right? Any questions?
No.
Okay. I want you to turn the page, please. Take a look at page 274. 274.
Next stuff looks difficult. This.
All right. Now, in terms of your tables, I want you to look at that table, figure out, number 5, is it linear, exponential, or quadratic?
Copy that.
Okay, number 5, volunteer. How many say linear? How many say exponential?
It's linear.
Quadratic. Okay, volunteer, tell me why it's linear. Bailey?
Because as x goes up at a constant rate, so does the y.
Good. As x is increasing by 1, y is decreasing by the negative 3, or increasing by negative 3, if you think of it that way. Okay? So if x is increasing by a constant and y is increasing by a constant, it's linear. All right. Now, in order for this next one to work, you have to fix their misprint. When they printed this book off, they misprinted this. This should actually be, this value right here should not be 6, it should be 4.
Yep.
And this value right here should not be 6, it should be 4. Okay? Now, you guys, another way to think about linear is you can think that the first differences in your y values, as long as x is increasing by the same, then the first differences of your y value are the same. So here you're adding negative 3. Here you're adding negative 3. Okay, now that would seem like a waste of my time. But if I go and look at this and say, hey, x is increasing by a constant. Y right here, that's adding negative 2, right? And here I'm going down 2 again. So if you don't like saying plus negative 2, you could just say you're subtracting 2. And here I'm subtracting 2. And here I'm adding 2 now. And here I'm adding 2. So am I going up by a constant? No. Some of you are missing this, and this is a key piece to figuring out your tables. I'm not adding a constant there, so I'm going to figure out what that's called my first difference right here. Why is it the first difference? Because it's the first difference between your y values. I'm going to figure out my second difference. In fact, you guys go ahead and figure out your second difference.
It's 2. From 0 is 2. From 0 is 4. It's first value.
It's 2. The second difference is 2. Is that correct? The second difference is 2?
Might be.
Might be. I think it's correct.
Okay, what do we get?
2.
If you have that common second difference, it's a quadratic. What I want you to do is I want you to make a table out of these values right here. Yep. And make a table out of these values on number 7.
I was asked problem number 7.
Give both those a go.
It's pretty simple to make the table, Tom.
What?
It's pretty simple to make the table.
No, it's not.
Okay. Hey guys, I need you engaged because right now how many of you have your tables done?
I have 1.
Okay. What is this going to be right here?
Negative 4.
Negative 4. What's this one?
Negative 1. 2. 5. 8.
Okay, what's this one?
5. 9. 0. 3. 0.
Okay, now would anyone like to, and I'll try to give you a hint here. Would anyone like to tell me why I said I need you engaged? Because we've made a major mistake, and you guys have just taken my word for it. And I do that when I'm like, this one's on purpose. Okay, I've let you kind of go down the wrong path. I've told you the correct answer, but I've kind of let you go down the wrong path, and not a single person in class has corrected me yet. Okay, so come on, this is all right, as the previous problem. You got it, Julie?
My book has different numbers. Yeah, so is mine.
Your number 8's different?
Yeah.
Oh. What are they?
Negative 5.
Negative 2. Negative 5.
Negative 1, 0.
Are yours the same?
Or mine's negative 1, 1.
Just copied it, bro.
So hold on. What's your table?
Mine's negative 2, negative 5, negative
Yeah.
1, 1, 0, 3, 1, 1, 2, negative 5.
Okay. All right. Well, let's do me a favor and copy this one just off to the side then for now. Copy this table, given these
Is
coordinates.
that what you're trying to trick us with?
That was not what I'm trying to go with on that. Okay, so if you have a different set of numbers for number 8, which sounds like some of you do, then if you have a different set of numbers, then go ahead and copy your numbers off to the side. Or copy, excuse me, these numbers off to the side and use those. Okay, you can just cross out the ones you had for number 8. Since I have no idea where those came from. Magically appeared. I'm still concerned about number 6 though. Like, no one has corrected the error. And there's a major error up there.
Number 6?
Because right now, everyone's agreed, hey, the second difference is the same. Gunnar, what's the problem? These are 4 and 2. Those are correct. Okay? Bill? -2 and -2 and +2 and +2. The difference here is what? That's a 0 difference. What's that difference?
4.
4, and what's this difference?
2.
That's 0. That is not a constant difference. So this can't be quadratic based on what we have written there. However, no. However, well, what? So, well, no, Isaiah, from -2 to -2, how far do you travel? 0. That's what we're doing with. Well, you don't travel anywhere, right? You go from 2 to 2. That's a distance of 0 on a number line. So from -2 to +2, that's a distance of 4. Come on. What's the problem with that?
It's not right.
It is not constant, so I will tell you that this is quadratic, and this difference should be constant. There is a mistake up there. You need to find it. I'm not going to give it to you. We'll sit here until class ends.
It goes.
Come on, every single person in here has the ability to find this mistake.
From 2 to 0, it's not 4. Or 6. From 2 to 0 isn't 4.
2 to 0, from here to here, is 2. It says -2, huh?
Just -2 to 2 is 4. To get from -2 to 2, you got to have 4.
I'm saying. No, that's not what I'm saying.
Huh?
Is it an obvious mistake?
Have a hint?
All right.
Should the 4s be 6s?
Okay.
I wanted a hint.
Okay, give number 8 a go. No, you're not done with 8. You just made a table, man. You got to tell me whether it's exponential, linear, or quadratic.
Oh, it's exponential. No, quadratic. Shut up.
Sarah, what do you think it is? Quadratic? How come? Okay, what do we change here? How much are we going here? Adding 9. How much here? How much here? How much here? Okay. First difference is not the same, therefore it's not linear. Okay, what's this?
6. -6.
It's how far you're traveling. It's the distance between them. -6. This is, second difference are the same, therefore this is quadratic.
This is confusing. So you just find
If the difference between the differences is constant, then it's quadratic.
Finding the second difference. Not too difficult on that
so you
one.
have to find 2 differences.
Well, you keep going until you get the same difference.
So you can find like 6 differences.
Sure, keep going, man, if you have to. Okay, try number 7.
It's that one's linear.
Don't just, you can't just say it. You can't just say it. You gotta do the work.
Okay, what's our first difference?
3.
3 plus
+3, +3, +3, +3. This is linear. Go back, go up to, or actually do number 9 first.
I wanted to do number 6.
I'm just gonna do numbers.
All right. What do you guys think?
I'm not done yet.
Not done yet? All right. Exponential? How come?
Because it's not like the differences keep like going bigger.
Did you find the differences? You did? What do we got here?
I got 16.
16.
So negative 16.
Yeah.
Minus
Here?
Minus 40.
Negative 48.
Here?
Minus 8.
What's this one?
112.
Okay. Did anyone try the second differences?
I didn't get to it.
Oh.
What did you say?
Down 32 every time?
Great job.
So what is that?
Quadratic.
Quadratic. All right. So let's go back up here. Okay, we've identified that the second difference is incorrect. Okay, or at least it can't be quadratic based on what we have here. How can we make it quadratic? Make 4 6s? Yeah. Yeah, well, we can't. I mean, normally, that's a good question. Normally, we're not changing the table. However, we started by changing the table, right? Okay, this table was this. Well, let's go ahead. Try to put the 6s back in here. See what happens. You don't want to. Come on, man. Hey, if you put 6s in there, does it work? You mean you have minus 4 then, right? Okay, so let's go with that. If we say, okay, forget it. We're not changing those to 4s. We're leaving them as 6s. Is it? You get minus 4, minus 2, plus 2, and plus 4. What's the difference here? 2. What's the difference here? 4. And here? Didn't work. How can we make that quadratic? Make these 8s? No, you're not allowed to change the number. Only on this problem are we changing the numbers. Gonna make it 8? All right. Let's do it. So what's that make this? 6? No. Only on this one. I'm trying. You quit asking the same questions? No, you can't change the number. You were only doing that for this problem. Come on, man.
It's going to work.
Did it work? What's that make that? Makes that 4? What's that? What's that? Okay, it is now quadratic. Hey guys, really, rather than skipping this problem on here, the book messed up. Okay, the book gave you, it didn't mess up really twice. I mean, we could have changed, I could have changed any of the values. I could have actually I could have made that a 4 and that a 1. Okay, but hey, the book made a mistake. I'm trying to get you to think through it though. So everyone that keeps asking, can we just change our numbers in our tables? No, you can't. You have to use what they give you normally. Okay? No, you can't make it whatever you want. It's like a millennialist dream here. Like, can we just make the problems be whatever we want? That's awesome. Okay? No. All right. Hey, just make sure we're clear. Subtract 6, subtract 2, add 2, add 6. The difference here is 4. Difference here is 4. Difference here is 4, so it's quadratic. Okay. Are we good? Okay.